Okay. Hi, guys. I'm Eugeny. I'm with OpenCraft, and today I'm going to tell you about searching words in Courseware. So basically, yesterday proved that I'm really bad at estimating talk length, so I'm going to really blaze through it, and then we'll have some time for questions. And I don't really want to be the one guy between you and the rest of your plans for today. So let's go. Yeah, here's my email. Here's OpenCraft logo, and fire. So this is the talk outline. I thought I would be original with "you are here" sign, but yeah, everyone else uses it, so it's not going to work. So we are here at the talk outline. So next thing I'll talk about is a really brief introduction to what full-text search engines are and how they are used and what's inside of them. Then we'll talk about one particular search engine that are used in EDX platform, which is Elasticsearch. Yeah, again, brief introduction about ways to talk to Elasticsearch from Python. And finally, we'll get to the larger part of the talk, I hope, is searching Courseware and other stuff. OK, let's go. Introduction. I'm going to skip this slide because I've got a better one. So basically, you can have full-text search in 3 different flavors. As a library, which is like low level, you do everything you want, but you need to write all the stuff around it, like feeding the data and querying and so on. As a relational database extensions, like every major SQL database have some kind of full-text search, including most popular Postgres, Microsoft SQL Server, and so on. And as a standalone server. There are 2, tens of them, but most popular are Apache Solr or something like that, Elasticsearch, and Sphinx. And we'll get back to the previous slide, which basically outlines how it works internally. So I think Dijkstra said that algorithms plus data structures equals program. Someone really said that. I just don't recall who exactly. So, and it's really convenient to think about full-text search engines using this dichotomy. So for algorithms, we have normalization, which is basically transforming the word into a form that is convenient to store and search for. Basically, it's stemming, removing stop words like the, of, any, and so on. And synonym substitution, like jump almost equal to leap, almost equal to hop, and so on. Query analysis, basically when you transformed your original text into a form that is suitable for searching, it is quite different. So for example, word transparency would likely be reduced to just transpare. And set would be still set. 5 might be 5 or just a number, and so on. On the other hand, searching for something usually uses natural language, which still consists of the full-blown words. So Query Analyzer performs basically the same transformations on a query that normalization do to the original document. And finally, there's advanced queries that allow really nice features like searching for a phrase with some certain word proximity, regex searches, and using multiple fields as data sources. On the data structures, actually, the main data structure used in full-text search is inverted index. Really, I don't understand why it's inverted, because what it is actually can be found at the end of every serious book, and it's called just index. So basically, it tells where the word, it's a mapping between the word and the position in the document where it is. Looks like that, roughly. It's an example from Elasticsearch documentation. OK. So Elasticsearch. It is a distributed full-text search engine with blah, blah, blah. I'll explain a little bit more on that. So horizontal scalability is one of the holy cows of modern computing. And it really has that status for a reason. I think we'll get back to it really soon. document-oriented schema-free approach basically means that your documents are like, there are no schema that is enforced like in relational database structures. It's more like NoSQL storages and so on. And RESTful API and built-in multi-tenancy support. So how many of you don't know what RESTful is? Cool, we skip it. So there's one thing that really, one term that really have somewhat different meaning in full text context, and especially in Elasticsearch context, is document. In that context, document is a top-level object. Really, think of it as a JSON object, just a collection of keys to values mappings, and store it as a root object in an index and having unique identifier. So as you know, JSON objects might have nested objects and so on. Document is a top-level object only. Only that object have unique identifier and can be searched in a query. So, and there's two different kind of fields: exact value fields and full text fields. Exact value fields are stored as is, not analyzed, but added to an index, and still have dedicated inverted index. Full text fields are analyzed, so they are split to words, stamped, synonyms replaced, and so on, and can be queried for partial match, inclusion, difference, word distance, and so on. So Elasticsearch really built with horizontal scalability in mind, which means that it has distributed storage and it is really decentralized. There are no master node, no predefined master node. Cluster is really dynamically constructed, so only thing you need to do is to spin up a new instance of Elasticsearch, tell it that it belongs to that cluster name, and then by some black magic it just finds other parts of the cluster, notifies them that it exists, and everything works. Next thing. So over the years, Elastic company, which are creator of Elasticsearch, developed a lot of other stuff, and the most important ones that are really frequently go together are ilk. Well, not that ilk. This one. It's Elasticsearch, Logstash, and Cabana. So basically, Logstash is a tool that collects your logs and feeds it, pre-processes it, and feeds it to Elasticsearch for storage. Cabana is kind of user interface that allows building reports, analytics, and so on, and queries, Elasticsearch for data. So the order they are used is Logstash, Elastic, and Cabana. Here's the question: shouldn't be called leak then? I don't think it shouldn't be leaking anything normally. So talking to Elasticsearch is really simple. They have RESTful JSON API that covers most of the use cases. I haven't listed, yeah, they're on the different slide. So basically, you just send that kind of thing. It is indexed, and then you can query using some query syntax, which is a little bit too complicated to show it here. So how do you talk to Elasticsearch from Python? There are basically three approaches. Down to the roots is to use API directly and any library for HTTP requests you want, like URL lib, URL lib2 request, and so on. The downside of that approach is basically you are responsible for constructing queries and sending them. The second one is Elasticsearch Py. It is official client written by Elastic to official Python client written by Elastic. It basically repeats API in terms that you still construct the same queries, but as Python dictionaries. And there's Elasticsearch DSL, which is a higher level interface built on top of Elasticsearch Pi. It provides more Pythonic interface and some nice features like kind of ORM capabilities and so on. So to give you a grasp of the difference between them, here's basically the same query written in Elasticsearch Pi and Elasticsearch DSL. As you can see, DSL version is kind of 2 times smaller and like more maintainable. On the other hand, there are some complicated use cases, not sophisticated use cases that you can't really replicate with DSL. So what can the API do? Create, request, update, delete, which have a little bit different names. Searching and aggregating on the data. Index management, so you can create, update, create indexes, delete them, change mappings, and so on, using the same interface as you would with indexing and querying documents, and updating cluster stats and some of the configuration. But there's one thing that is really missing, and I would really love it to see it, is migrations. So you can't really change how the data is structured in Elasticsearch without rebuilding an index from scratch. But index aliases save the day by allowing you to create an index, alias it so that your application stuck to an alias, then create a new index in the background, and then just switch the alias to new index. Next, searching Courseware. So I believe everyone's seen that at least once. So there is no point to go into long explaining what's happening here. But basically, that search field on the top sends AJAX requests to LMS backend, which is implemented in Elasticsearch application we'll talk about later. And that search is transformed to a search query, fed to Elasticsearch, and then data is passed all the way back. So it's important to note that it has limitations. So it can reach HTML and text modules, KP problems, all kinds of problems, videos with transcripts, and custom X blocks if developers paid attention and implemented the API to include their X block for indexing. So what it cannot reach? Discussion threads, unfortunately, and I'm really surprised that they're not searchable as is. Most custom X blocks, tools that are not actually on your instance, like LTI modules, iframes, and so on, and anything in draft version. So if your courseware is not published, it's not added to a search. So any technology that is really advanced, any sufficiently advanced technology is indistinguishable from magic. But it doesn't mean that it false positive proof. So here, Courseware search found meaning of life in demo course. It basically happened because of slightly suboptimal configuration of the Elasticsearch cluster. What exactly happened is that it found meaning of, no, that's not the, so it found meaning of and life in completely different places of the document and reported it as hit. The second problem is that of should be a stop word. It shouldn't be indexed because there are lots of uses of it in a normal English speech, which indicates that Elasticsearch do not use appropriate analyzer. I think we'll get back to it a little bit later if we have time for it. So here's basically what happens when user publishes a course. So Studio emits published event, which then is intercepted by some other part of the code. That code spawns auxiliary task that walks module store, fetches module instances, and then that task asks module instance to provide indexable representation. And then it recursively walks all the core structure. That index representation is then fed to Elasticsearch and stored. Searching is a little bit simpler. So basically, search clause is sent to LMS frontend, which is then transferred to EDXSearch application through AJAX request, transformed into Elasticsearch query, fed to Elasticsearch, and then results come all the way back. So closer look to EDXSearch. This is a package and Django application to provide search capabilities to EDX projects. Interface is storage agnostic, so it should be able to work with Elasticsearch, Solr, Lucene, whatever. But so far, only Elasticsearch is supported. It supports searching across different courses. So Courseware Discovery Search works exactly the same way as searching within a course, except it's not limited to a single course. And the nice thing is that EDXSearch tries to automatically generate appropriate Elasticsearch mapping for data, but as we've seen earlier, it doesn't really do that very good. So primary component of that EDXSearch application is Elasticsearch Engine. Basically, it's a wrapper around Elasticsearch Pi that adds some EDX-specific value to it. In 2 words, the main method in it is search. And it allows doing Google-like search over content fields, allows doing exact value matches on the like usernames, IDs, course IDs, dates, and so on. And yeah, it provides some filtering of the requests, so you can't really use search clause to construct really complex queries, which might be good or bad because it prevents from advanced users from doing really fancy stuff. Yeah, it was supposed to be like fade in, but since it's PDF, it's all in one slide. So you can find all videos in the course with content type video filter. You can get all modules not yet visible to students, like with start date. You can search across queries by not specifying course ID, and you can search cadence everywhere. So future applications. Elasticsearch is really like NoSQL storage with really good horizontal scalability. And it's kind of really similar to NoSQL, which is used in EDX for a module store. So now I'm talking about replacing MongoDB with Elasticsearch, basically. It should be possible, provided some effort is put into it. Second thing is ELK-based analytics. I talked to guys from Insights team yesterday, and they said that they have considered that, and basically their aggregations is a little bit too complex to be expressed in single Elasticsearch query, which does not really allow to doing so. But that's so this slide is a little bit outdated. And finally, what would be nice to have is to provide some kind of XBlock interface to allow XBlock searching over Courseware or adding some data to Elasticsearch indexes and doing something about that. So that's it. Questions, suggestions, and so on? Sure.
Do you have any suggestions on deploying Elasticsearch? Because I know that's one service that seems to kind of grow unbounded and like to eat computer resources.
Yeah, well, frankly, I didn't have any problems with deploying it. So I haven't thought about that. But, well, speculating, you could deploy some, it's Java virtual machine. So you can deploy some Java limiting stuff like configuration and so on. Sure.
Actually, I can speak to that very briefly. There are two very simple ways of deploying Elasticsearch. One is to use the Ansible playbook in the configuration repo to configure Elasticsearch. It might be a slightly old version, but if it is, you should fix it. The second would be Amazon Web Services has a hosted Elasticsearch product, which I highly recommend.
That's it. More questions? Go on.
What's the main advantage of using Elasticsearch instead of building those full text indexes in your database?
Basically, full text indexes in databases are limited to what they can do. So standalone servers allow for more complex queries to be constructed and executed in a more efficient way. But yeah, the problem is that there are no migration path between full text index in a database and the standalone server. You will have to basically export all your data and re-import it. It would be a nice approach to start with something similar, something smaller with the relational database index, and then migrate to full standalone solution. But unfortunately, there are no such things yet. Okay, I think that's it. No? Sure.
I kind of like the idea of using Elasticsearch as a NoSQL data store,
Yep.
but I think there are some downsides. I'm thinking specifically about backups. Like, is Elasticsearch, are the indexes, are they persistent, first of all? Like, will they survive a restart, or do you need to re-index data?
Yeah, sure, they survive. Yeah, so first of all, yes, they are persistent. So whatever is indexed, it can survive cluster restart, node restart, cluster restart, everything. So basically, it is a distributed solution. So I think it's even more stable than MySQL relational databases because of that distributed character. Into words. Go on. That guy really knows more than I.
Jello, just to piggyback off that question, have you looked into potential issues with the fact that Elasticsearch doesn't support any transactions?
Yeah, that's an issue with Elasticsearch, and well, frankly, we don't do as much changes to module store as would require transaction support. So, I think it is affordable tradeback for now. In the past, when I worked in a more dynamically changing environment, what we did is we just basically wrapped. We used Elasticsearch as a secondary data source, only for search, and relational database as a primary data source. And we have wrapped adding data to relation database and Elasticsearch into a single encompassing transaction, which is more expensive solution as well, just performance-wise.
Yeah, another question I had about that. Using it as a data store, does it support user-based access rules? So in my experience, you have this REST API that you can poll. Does it have the same control, like preventing one user from accessing the database?
Yeah, I think what you need is this.
Oh.
That's can't recall. But I think it's Shield or something. So basically, it's an app or like plugin for Elasticsearch that allows ACL. Or you can do that on your application level. That would be simpler. So if you tend to expose Elasticsearch to the world, you need that. If all the requests are passed through your application, you can do it on application level. Cool. Thank you, guys, for coming.